Hi guys, welcome back to AMMA SAT. So we're gonna have our episode 15. So coordinate and geometry. So that's what we're gonna tap on. So let's just get to the problem. So the SAT likes to test linear functions. So that's something that you want to focus on. So linear functions, graphs. We did have a drill dedicated to linear functions before. Just check that drill out. So we also have area, volume, real. We're gonna look at that chapter a little bit later. About this problem over here, let's just try to solve it and try to recall some of the rules that we have learned. Alrighty, so a line passes through the origin. So the origin is where the x-axis crosses the y-axis, right? So y-x, so this point is 0, 0. So that's origin. And then the point 5, 15. So what is the y coordinate of the point on this line where x is equal to 2? So in order to find the y coordinate of this point, it's better for us to get the expression of the function out, right? So remember, we learned about how to get the function out when we know 2 points of a linear function. So it's a line, so it's a linear function. Then we have 0 as one of the points and 5, 15 as the other point. So the first in the formula, the first one is y1, the second one is x2, y2. Still remember that, right? So and the slope is y2 minus y1 divided by x2 minus x1. So the slope is going to be 15 minus y1, 0, and x2, 5 minus 1. So the slope is going to be 3. All right, so once you have the slope is 3 and it's passing through the 0, 0 point, we can use this y is equal to mx plus b formula to get it. So y is equal to m is the slope is 3, so 3x plus b. Right? Since the function goes to 0, 0, so if you plug 0 in x and you find out that 0 plus b is equal to 0, right? So y is also 0 at this point. So b has to be 0. So the function is y is equal to 3x. As a matter of fact, any linear function which goes through 0, 0 should have a b which is equal to 0. All right, so some of the experience along the way. All right, so once you have this function, and then when x is equal to 2, then y is equal to 6, right? So let's just put 6 in here and check the answer. And still you can ask Emma to explain, right? So actually, she is doing the same thing. So let's put much that problem. Let me see if we have any other things that we want to talk about. So let's just look at this linear function problem again. Let's clear the draft paper. And if the point K10 lies on the line y is equal to 2x plus 4, what is the value of K? I just plug K as x in. So 2K plus 4 is equal to y, and y in this case is 10. And then 2k is equal to 6. K is equal to 3. Let's put it straightforward. So let's just put 3 in here and then check the answer. If you want to use decimals to solve this problem, it's also okay. Just input the function here. So y is equal to 2x plus 4, right? And then you have the function. You only have to find where y is equal to 10. So let's just make this really big. So y here. So this is y is 10, and then it goes down to x is here, so 3, right? So you can still see that too. Still, you can use that to solve this problem. You can use decimals to solve this problem. All right, so I promised you that we need to go back to the textbook for the real world geometry, and let's see what we can learn from this thing here. And basically, it's about the formulas of how to find the length, the area. The area for a rectangle is the length times the width. And the area of the triangle is base times height divided by 2. And then the area of a circle is pi times r squared. And then the area of a trapezoid is base is top plus the bottom times the height divided by 2. So you have a trapezoid, and this is B2, and height might be here. And then B1 plus B2 times h divided by 2. All right, and then the rectangular volume of it is V is equal to the length times the width and then times the height. So this thing. So basically is the area of the bottom times the height. And then for a cylinder, it's still the area of the bottom times the height. Only this time, sorry, it doesn't look straight, so it goes this way here. Goodness, I hate to draw on the whiteboard. And then you have the area at the bottom of the circle, so it's pi r squared times h. H is the height. So you have this formula over here. And for a cone, it's only 1/3 of the volume of the corresponding cylinder, right? So just draw it out. And it still is the area of the bottom times the height divided by 3. So the bottom is pi r squared times the height divided by 3, right? And the sphere is 4/3 times pi times r cubed. So these are the very common formulas. Some of the formulas are provided by the reference paper, but not all of them. If you know these formulas, it's not only about how well you can memorize things, it's about you can build up your thought chain in your mind when you think about a problem. All right, so, and then you can use these practice problems to check your mastery of such formulas. And along the way, you can always click Emma and call her out to talk about these problems here. You can use the select button to select the problem that you were working on. Let's just select it. And then you have to send to Emma, right? And then the problem is sent over just in one click. It's pretty convenient. And you can also select the whole screen to take a screenshot and send it over. And see, and she has already explained it, right? So guys, that's all for today. I'll see you guys next time. Bye-bye.